Okay, we've all been blown away by what modern AI can do, right? I mean, models like GPT, they write code, they create poetry, they can answer just about anything. It honestly feels like magic. But what if I told you that all of this magic has a fundamental flaw? A hidden cage that's seriously holding back its true potential. Yeah, what if the very architecture of these incredibly powerful models is the problem? Well, today we're going to dive into a fascinating new paper that doesn't just point out this core issue, but it also proposes a pretty radical way forward. And it all starts with something the researchers call the autoregressive prison. All right, Section 1, the problem, the autoregressive prison. So the researchers behind this paper say the core issue is this thing they've dubbed the autoregressive prison. You can kind of think of it like a cage that almost every single large language model we use today is living inside. So, what exactly is this prison? So, at its heart, autoregressive generation basically means the model writes everything step by step. It spits out the first word, then based on that word, it figures out the second word, and so on and so on. It's constantly looking backwards to decide what to do next. But here's the kicker. It never ever has a high-level plan for where the whole thing is supposed to end up. This right here, this puts the problem into perfect perspective. So imagine you ask an AI to write a movie review. A standard model, a standard transformer, just starts writing, word by word by word. It's literally figuring out if the review is positive or negative as it's writing it. But that's not how we work, right? You and I, we decide first. We think, okay, that movie was amazing, I'm gonna write a positive review. And then we pick the words to fit that plan. The AI's way of doing things? It's like trying to drive a car while only looking in the rearview mirror. You have no idea where you're going. And that's the real danger. The paper puts it perfectly. It may be sent off track if, by mistake, a few tokens generated are erroneous, ambiguous, or contradictory. Basically, without a plan, one single wrong word can send the whole thing spiraling completely off course. It's super fragile, it's inefficient, and it's like trying to build a house brick by brick without a blueprint. So the big question is, how do we break the AI out of this prison? Well, this brings us to the solution, the free transformer. And this is where things get really exciting. It's a totally new architecture designed to give the model the one thing it's been missing, the freedom to think before it speaks. So the big idea is actually pretty simple, but it is incredibly powerful. The goal is to give the model the freedom to make a high-level plan before it starts writing anything. Before it generates a single word, the free transformer comes up with this plan. You can think of it like a North Star for the entire piece of text it's about to create. Now, technically, the paper calls these plans latent variables. And the paper has this awesome analogy to explain it, the secret coin flip. Let's go back to that movie review example, right? Before the model writes a single word, it gets to make a secret coin flip. It's a hidden decision, a latent one, that might land on positive or negative. And that one secret decision that guides every single word it picks from then on, making absolutely sure the final review sticks to the plan. Okay, so how does it learn how to make these plans in the first place? Well, it's a really clever two-part process. So during training, you have the first part, the encoder. Its job is to read a complete example, like a fully written positive review, and then it works backwards to figure out, okay, what was the hidden plan here? It boils that plan down into that random variable, our secret coin flip. Then the second part, the decoder, takes only that secret plan and tries to regenerate the entire review from scratch. And by doing this millions of times, the model gets ridiculously good at both making and following these high-level plans. All right, Section 3, the evidence. How does it work? I mean, this all sounds great in theory, but does it actually work, right? Does giving an AI this kind of freedom to plan ahead make a real measurable difference? Well, to find out, the researchers set up this simple but totally brilliant experiment. Okay, so here's the test. It's a synthetic data set. The researchers created these long sequences of underscores, and somewhere inside, at a random spot, they placed a target string of letters, like a bunch of T's. The goal was super simple. Could the model learn to use its latent variable, its plan, to decide where to put that target string before it even started writing the sequence? So for result number 1, they gave the model very little freedom, a really low KL divergence, as they call it. And the result? It was a complete and total failure. You can see it right here. The target string is just scattered all over the place, totally random. It's behaving just like a standard transformer, just guessing as it goes. It is still stuck firmly in that autoregressive prison. But then, they gave the model more freedom, and bam! This is the breakthrough moment. Success.
The model uses its latent variable, its plan, to first decide the target's position, and then it writes the sequence correctly. Every single line you see here was generated from the exact same secret plan, and just look what happens. The model nails it, putting the target string in the same spot every single time. It made a plan. I'm going to put the target here, and then it executed that plan flawlessly.
And believe it or not, it gets even better. With maximum freedom, the model didn't just plan where to put the target. It also planned where to put the random noise, the exclamation points surrounding it. This is huge. It's proof that it's not just making one simple choice. It's encoding complex, structural information into its plan before it writes a single character. So, okay, that's a cool synthetic test, but how does this translate to real-world tasks? Well, the results are seriously impressive. This is a breakthrough in reasoning tasks. On an 8 billion parameter model, giving it this freedom to plan led to some major gains, especially on tasks that require real reasoning. I mean, just look at the coding benchmark, an improvement of over 11%. That's massive. And we're seeing really solid gains in math problems and general knowledge too. This is some of the strongest evidence yet that planning ahead is the key to unlocking more complex AI reasoning.
So, let's wrap this up. Conclusion: is freedom the future? After seeing all of this, you have to ask the big question. Is this freedom to plan, is this the future of AI?
This quote from the paper just nails the core difference here. It says this approach aims at achieving in latent space what reasoning models do with chains of thought in token space. Okay, what does that mean? Well, a lot of current techniques, like chain of thought, are basically trying to force the model to show its work out loud, right? It thinks step by step in the words it's generating. The free transformer is way more elegant. It does all its reasoning internally in this hidden thinking space before it even starts talking. It's just a much more efficient and, honestly, a more natural way to solve a problem.
So let's just boil it down. Why does this matter? Well, first, it's a totally new way for AI to plan and structure its thoughts. It also means we could get models that are way more robust, less likely to get sent off track by one little mistake. And we're seeing these huge performance boosts on tough reasoning tasks with almost no extra computation, which is a big deal. Ultimately, this feels like a real shift, a move away from just step-by-step generation to a more holistic, plan-based way of creating. So we've just seen what happens when you give an AI the freedom to plan. And it really makes you wonder, doesn't it? What other freedoms could totally change the future of AI? What other fundamental limitations are we imposing on these systems without even realizing it? What could we unlock if we just let them think differently? I would absolutely love to hear what you think. Drop your ideas in the comments below.